All right, so in this video, we're going to go over electron configuration just as a review. And really what you want to do here is you want to use the shape of the periodic table to help you. And so remember, the shape of the periodic table comes from quantum chemistry. It comes from quantum numbers. These two, right, this two wide a section of the periodic table, that's the S block. This is the P block. 10 wide is the D block. And at the bottom here, those are the F blocks. An F block, remember, we just put separate from the periodic table. It looks separate. It's not really separate. It's really inserted right here. It's just for space reasons that people do it like this, okay? But so, it's a good idea to practice annotating your periodic table just like I'm going to do. This will get you basically any answer for any electron configuration for this course, okay, if you can do this annotation. And so these first two, hydrogen and helium, are the 1s. And I'm going to write these in the order that they're filled. Lithium and beryllium, that gets you to 2s. Boron to neon, that's filling up the 2p's. 3s gets you to magnesium. 3p gets you to argon. 4s gets you to calcium. The 3ds, that gets you from scandium all the way to zinc. Now, why is it 3d and not 4d or 1d? That has to do with quantum numbers, so you'll have to review your quantum number rules on that, okay, that we talked about earlier in chapter 6. Gallium ending with krypton, that gets you to 4p. Rubidium and strontium are filling up the 5 s's, and then you get to yttrium all the way to cadmium. Those are 4 d's. Indium to xenon, that's 5p. Cesium and barium, 6s. And then lanthanum, see 56 to 57, that's barium to lanthanum, that gets you to 4f. Again, why is it 4f and not 6f? Quantum number rules, solutions to the Schrodinger equation, etc. Okay. But anyway, that gets you all the way to lutetium, 4f, that's number 71. And then you start going hafnium, that is the 5d, right? 3d, 40, 5d. That gets you to mercury, number 80. Thallium to radon, that's going to be 6p. Notice, right, this is the 6th row. The p's and the s's just follow the row numbers. The d is kind of -1, and the f's are -2. 7s, francium, radon. Okay, that gets you to the 5f for actinium through lawrencium. Rutherfordium is going to be the start of the 6d. These are getting to radioactive elements not commonly used. And from nihorium to oganesson, that ends you up with the 7 p's. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 rows in the periodic table, gets you up to 118. And so, that's just starting out. One thing, so if you can do this, if you can annotate your periodic table like this, you'll be good. One thing, you guys are very lucky. You're living in an age where the periodic table is basically complete. You have 118 elements and they're all named. When I was learning chemistry, starting out, your age, none of this, most of this row here wasn't even known if those elements were accessible. These are radioactively synthesized elements in large national lab type facilities in synchrotrons. Really fascinating stuff. Will the periodic table end here? We don't know, right? It's possible, and I think, in my opinion, pretty likely that within our lifetimes we're going to go out to probably 130 or even further. And actually, at that point, you'll start incorporating g orbitals, okay, which is kind of cool. But anyway, that's it for this video. Now, the next video, that was just a review on this. Let's actually go into doing the problems in the next.